All right, the recording has started. Welcome both. So, last meeting, we were talking about sensor data. We're talking about collecting sensor data to upload to the cloud. What kind of sensor data would be useful? And we kind of agreed that it would be great to make a blog post out of it. So, what we're doing today is continuing that. It's we got to a point of we think the important things to note are X. So let me quickly load up where we got to and send the links over, because I think that'll help explain. What was it? Discussion data? Yeah, that was it. Okay. So there's 1 and 2. And I'll send the links and then I'll share my screen so I can show where I am as well. That's a spreadsheet. Good. And then, okay, so I'll start with the spreadsheet because this is kind of where we started. So my initial idea coming into the meeting was, let me boost this up a bit. There we go. My initial idea was that we could create a chart like this of importance on the x-axis and how big the data is, bigness. I guess you could say size, but I think bigness emphasizes how rough we're talking as a metric. So the idea that I brought in was, hey, camera data is somewhat important and very big, and log data is very important and pretty small. So by those metrics, you can sort of figure out, working from the bottom right up to the top left, what is useful. And then through discussion, we figured out a few things that we might want to include as sensors. And then we kind of said, actually, how important it is pretty hard to define because it kind of depends on application. So we swapped over to a Google Doc, so I just need to switch to that. There we go. So we kind of switched to this instead, and this is where we got to. So can we define a couple of categories, like humanoid robots and submarine robots, for example? It could be something else. And then for each of those categories, describe them, decide what data is most important to capture, and then make that kind of a chart per category. The idea being that data is important for humanoids, so telemetry is really important for humanoids, for pretty much all applications of humanoids, presumably, but not as important for submarines. And then by doing that, we can create, we can allow people to contribute their own categories, their own important data, and we can make a sort of reference guide. If you're doing a pick and place robot arm, you would go to the pick and place robot arm category and see, I need to make sure that working from the bottom right to the top left, I think that I have the data I care about most. So,
I love this discussion, by the way. This is so central to what robotics companies struggle with. And I also have a lot of thoughts. One of them is Foxglove is in the business of doing this, right? They have a product. They used to call it Data Console. I think they renamed it. That's one. So I feel like there's a little bit of an authority question here, where I almost feel like I almost don't feel entitled to say too much because I know there are people who know so much more about it. But there is something that I do know about this, and that is, and I have seen this both at Savioke as well as I'm seeing now with transitive customers, and that is a dimension. There's two other aspects that you really need to capture. One is the moment, like when do you care about video data? When do you care about point cloud data? When do you care about IMUs? Meaning, like, something has happened in the deployment where you want to debug it, you want to monitor it. Usually it's the debugging case, right? And then it very much depends on So there's the moment and there's the purpose. So for instance, I'll give you an example. At Savioke, we used to have this tool. It was written by an intern. We called it Backboy. It was really cool. It was a way to upload back files, or make it easy to watch back files where every time the robot would stop unexpectedly during navigation, it would take a snapshot of what the robot currently sees, like just all of the cameras. And then in the camera image, it would circle the area where, based on the point cloud data that we had from the 3D sensors, an obstacle was detected that threw the robot for a loop, right? Like this is basically trying to show, and that's how we discovered that shiny surfaces was a problem for the robot sensors, right? Because shiny surfaces, Giovanni's nodding, he's seen this, are terrible for a lot of 3D cameras, right? Because they blind out the projected 3D, like whatever image that they need for detection, and so they look like holes in the floor or like obstacles, whichever way. Anyways, the point is, if you're a navigation engineer and you're trying to figure out why did my robot stop, you'll be interested in very different data at a very different granularity at a very different sort of time scale, right? Like if in this case that I just described, it was perfectly valid to just upload one point cloud in the very moment that the robot stopped together with some images, and that was hugely helpful, right? As opposed to, obviously, the alternative to all of this is you always record everything, you upload everything, and that doesn't scale. Obviously that's kind of what you're capturing here as well. But I think it's very important. And then when you think about that, the challenge here is that it doesn't depend so much on the application, but it depends very much on the development life cycle. Like, what are you currently developing? Are you currently debugging navigation because there are some issues that you've seen, from the business case, your customers have complained, or whatever, you have downtime or something like that? Or like in the humanoid case, right? A lot of humanoids, let's be honest, these days are still in development. They're not actually in production. So in development, you have very different needs. However, you also with the robot, so bandwidth is typically not that expensive. So you may be able to upload almost everything or a lot more, which is yet another dimension that companies struggle with, right? Like if their robots are deployed around the world and they're connected over LTE, you may not be able to upload everything. Maybe you have a hybrid model where, sometimes you're on LTE, sometimes perhaps while you're at the base station, you have Wi-Fi and so forth. All of these things make it very difficult. So I can tell you that I'm working right now with some customers who've expressed interest in video recording. And a lot of the questions there are about, when do you upload and what's the retention policy and so forth.
I find it, Christian, I find it every time interesting that you start by saying that you don't know much about something. There's people that know more, but you always know a lot, and you always have very, very good insight.
It's the thing that you know from academia, right? Like when you leave high school, you think you know everything, then you do your master's and you know nothing, and then after a PhD, you know that other people don't know anything either. It's the more you know about a subject, is that where you discover how much more there would be to know, and it's more like opening your eyes rather than anything else.
Dunning-Kruger.
Dunning-Kruger, or
yes,
Aristoteles before.
Yep.
Yeah, I mean, I find it very interesting what you said, especially about the moment and the purpose. What is important is the moment and the purpose for collecting data. While you were talking about the fact that you were dynamically triggering what you were monitoring or what kind of data you were collecting, it reminded me of 10 years ago or even more. I think it was 2008, 2010, something, 15 years ago, where I worked a bit with people that do monitoring of applications in general. And one of the things that they had was indeed the fact that they wanted to have probes that you could switch on and off remotely on demand. So you dynamically adapted how much you were logging and how much you were streaming login data, depending on how the system was behaving, basically. which is very similar to what you were saying in robotics, with the difference that, yeah, as both of you said already, robotics can generate a huge amount of data very, very quickly. And we were working with just distributed web services, so that that was peanuts in comparison to robotics.
I think it's a good comparison though, right? Like, because in some way, I mean, what you're alluding to is that logging, which of course is a huge subject in all sorts of technology, is very similar to what we're discussing here. And so some of the questions that we're rediscovering here, like you pointed out, have been asked there before and solved, right? Like this dynamic switching of log levels and like per log category or file or whatever, scope. Obviously, that's something that they have invented before. The main difference was is the volume, really, and I guess the type of data too. But that's in some ways secondary, because it's you upload it at that point. It's just bytes, so it matters how big it is. Yeah, it's a very good point.
It also
I
made
didn't
me
mean to
think.
derail you, Mike. It's just that I missed some of these previous discussions, and I had seen the notes, so these thoughts were on my mind. And I know I'm coming a little late to the party, but I thought I'd share it up front. This is still a useful analysis. Don't get me wrong.
I agree with Giovanni. You always come with good insight, so I'm glad to have the extra thoughts. I think 2 points. One is quickly that I'm glad you let the idea. It was Giovanni's, so I'm gonna give him props for suggesting it. That was a couple of meetings ago. And then the other thing was, I do agree with what you're saying. I think some of it we skim over by saying if you need to reduce data rate, which is very likely, then store locally, upload a downsampled rate, compress before upload, that kind of a thing. So all of those questions about dynamically capturing data, that could be another option, dynamically capture data, right? Which is something that I've done in the past as well. So
there's also the on-demand upload approach, where you basically store on the robot, with a whatever rolling window, and then if you want to debug something further, I mean, let's just talk about bag files, because that's sort of the most typical application. That's what a lot of people do, right? They keep their files on the robot. Maybe they allocate some 20 gigabytes. Once, if they're full, then the old ones get deleted. It's a little bit like a black box. And then if they do need them, they can request them on demand.
Yeah, this is also done with drones many times, that you're only streaming a subset of the data that you need for flying around, but then you're keeping the whole bag on an SD card or an SSD, and then you're downloading it once the drone comes back. It's also done more and more with robots. I think Foxglove also has this tool now, also for not just for directly collecting data online, but also for bags. So if I'm not mistaken, or maybe I'm confusing it with something else.
Yeah, they used to have I think a fairly basic approach, where I think they uploaded all of the files, MCAP or bag files. And I think that was done through that Foxglove agent. And now just recently they announced Foxglove SDK, which I haven't fully parsed yet, but I think it's basically it's an SDK robot side, if I understand correctly, that allows you to programmatically stream things to Foxglove for both, I think, maybe for live inspection, but I think also for storage and then post hoc analysis.
Something that also comes to mind, but you are even more expert on this. I was looking again at the web UIs for managing robots and these sorts of things. I don't remember this one that I found. What was it called that raised the case? But I remember in the little README they were saying, we built this tool to remotely debug our robots. When our robots would get stuck, rather than being able to collect all the data we needed, what we did was basically start up a web UI on the robot, connect to it, and verify why they would get stuck, which is the alternative to to what you were discussing with Savioke, which was smarter. You have an automated way of just collecting this data and then sending it over. Instead, they would connect.
I think you need both, because the Savioke approach only works when you when ahead of time you can define the trigger conditions, when you want to see it. And of course, that didn't cover everything, right? A lot of times something unexpected happened, like an unexpected thing, right? And then you still need back files and Arvis or whatever it is. So yeah, and I think then it's better to connect to the robot and get sort of a live view there rather than always uploading to the cloud.
I agree.
Yeah, but yeah, and I want us to get back to this analysis, because there is this question of what do you actually want to always upload, and telemetry is a good example of that, right? Like things that is relatively lightweight, but give you a good sense of a good high-level view of your fleet. So one thing that a lot of companies with like larger fleet sizes want is they basically want a way to detect regressions after a new release, right? Because you can test all you want. Robots work in the real world, which we all know is very unpredictable, and you can't perfectly simulate it. So you're always wondering, okay, whatever. We released version 2.1 of navigation yesterday. We hope to have fixed these 5 bugs and hopefully not created new regressions. How do we make sure that is actually the case, right? We've tested it in simulation 1,000,000 times. We ran it in the office 100 times, but there's nothing like testing in the real world on your fleet of 1,000 robots. So how do you, at that point, instrument your code to upload data based on which you can sort of conclude, yes, it's fixed, or no, it happened again. So these types of, which really falls under log ingest at a large scale. And I think that dynamically enabling approach that you mentioned, Giovanni, I think is a good one here, right? Because if you can do that while the fleet is running, right, you can just turn it on a few robots for a while and then come back the next time.
Yeah, it reminds the other company that was we mentioned Foxglove, but the other one that came to mind when we were talking about logging robotics data was Formant, actually, that was specifically doing that from the beginning, if I remember correctly.
Yeah, it's definitely that was their opening proposition. They added from what I understand, they added video streaming and remote teleoperation later, actually through an acquisition of a company called Formation. I don't know whether that was a coincidence that it was called so similarly or not, but yeah, so this data sort of collection, and there's now a number of players in that space, but yeah, Roboto AI. I don't know whether we had Benji here speak at one point. They're also actively working on that. They all seem to have different opinions or niches, perhaps, that they focus on.
There is also this big movement now that I'm seeing again with the Ken Goldberg leading the pack again on now collecting so much data from the real robotics environment to then be used for model training, because basically there's nothing as good, as you were mentioning before, there's nothing as good as real data. Sometimes simulations, although they're improving a lot, sometimes they don't cut it. And so the real data, which is hard to get and expensive to get, is the secret sauce of many companies now. So
yeah, lots of interesting ideas in that space. I'll start with Tesla, right? Because Tesla has taught us about shadow mode. I don't know whether you've heard of that. Basically, the idea being that while people drive their Teslas, they are training the self-driving, right? Or at least they're potentially collecting data for self-driving. Now, if you have a fleet the size of Tesla, your fleet is too big to upload everything. So what do you upload? That becomes the million-dollar question. And so they came up with this idea of shadow mode, where the self-driving software is actually running the whole time, even when you're driving, even if you don't have full self-driving package. it's running all the time, and it's making its own decision as to what it would be doing now if it was the driver. And then what they do is they compare to what does the actual driver do, and they have a sort of like a likeness measure, like a distance measure between what the AI was suggesting and what the person was doing. And then guess what? When the person is doing something surprising, something that is very different from what the AI would have suggested, that is valuable information, right? So they prefer to upload that to the cloud, and then they can train on that, and then they can evaluate and see, well, did the person make a mistake, or would the AI have made a mistake here, right? Was it the right thing to do what the person did? And that's a very effective way to collect the training data. And now fast forward to humanoids, right? I was at the Stanford Research Center opening some couple of months ago, and Sergey Levin from Physical Intelligence was on stage, and the question came up on, LLMs work so well because the data is readily available. It's called the internet, and you need sort of that scale data to become as good. So how do you come up with that data for humanoid robots? And the answer, I thought his answer was very interesting. He basically said, you need to make the data collection negative cost, meaning like you need to be able to find a business model where you get paid to collect the data, which is exactly what Tesla does, right? They sell the robot those cars for money, and the people drive them, for free, but they're collecting data. And so he's basically saying, and he didn't want to use the word teleop, but somebody on stage who I believe was also from his company did mention that teleop might be a key of the solution here. That you need to be able to deploy a fleet of robots that does something useful, and you're able to collect data that you then use to train the actual the actual application that you want to do. It's a little different animal, right? Like when you're collecting for training models, we're talking about much bigger data. I think I might be wrong, and it's slightly different from what back to reality robotics companies that are currently deployed and have hundreds of robots in the field or thousands care about, right? There they care more about debugging, health monitoring, performance monitoring, which is there. Telemetry can get you pretty far. Just seeing, does the robot stutter? Does it stop a lot? Which is very different from, okay, give me the 3D reconstruction of the environment that it operated on, which is what I would imagine you would need for humanoid training.
While you were saying this, it came to mind a workshop, a Cloud Robotics workshop. I don't remember if it was IROS 22 or even before that, but there was a talk by Melanie Wise, which was at the time the head of Fetch, and she was saying that all their deployed robots, they had an agreement. They have the agreements with the customers who actually use them, that they can collect all the telemetry data and all the data. So it's part of the contract that they are allowed to then use all the data that the robots collect for further training and for product enhancement. They would call it, but this would be the justification. But then that would be exactly this negative cost model of collecting robotics data, basically, by deploying it and then using it again to improve your robots.
So my hope, and I don't know if this would actually work, but my hope is referring to the drawing that I sneakily made while you were talking, is that if we have some chart of importance versus bigness, that we can draw a box of very important things that you would want in production versus somewhat important and somewhat big things that you would have in development. And I don't know if LiDAR is extremely important in development and not at all important in production, so that it doesn't fit the model. But to bring it back to the Google Doc is, I hope the data would somewhat stay in place, and then we can say, draw your own box, but this is what I would do in this case, sort of a thing.
I'm trying to think about this. Yeah, I mean, LiDAR is interesting because even on a normal robot, like a normal robot, I shouldn't say normal robot. It's presumptuous, but a mobile robot, right, with one that's driving on wheels, in a flat area where obviously 2D lidars are very common. Even that, right? I mean, a 2D lidar produces minuscule data compared to a 3D lidar, but even the 2D lidar is too much to store all the time, and that's partially because if you want, you can get that at 60 hertz from a lot of lasers, so that's too much. And then it's very sporadically needed. Like you definitely need it very urgently in the moment you want to relocalize a robot, which unfortunately still is required a lot in production, where robots get mislocalized, and then to localize it, you typically display the laser scan on top of the map. You drag the robot around. We're actually coming out with a maps capability where we have this feature. I can talk about that some other time, but I don't want to plug too much here. So you visualize the live laser scan, and then you move the robot with the laser scan around the map until you find a match. Typically, as a human, you get your intuition as to where it is through other means, right? Often through like a video, like a short video clip where you recognize things. And then you kind of drag it and rotate it until it fits. There you do need the laser scan, and it's very important. Otherwise, you don't typically need it, except again for debugging, right? Like if there were obstacles or ghost obstacles, very popular. Also for lasers, shiny surfaces are terrible, right? Glass can be very problematic depending on the angle that you're approaching it. You may see it or you may not see it, which is very confusing. Yeah, I think that is a good example of very moment-based needs.
So do you think that this kind of idea doesn't represent well? Is there a third dimension maybe?
I think it's useful. Perhaps it might be more constructive, though, to not use either submarines or or humanoids, simply because there's not. I mean, submarines perhaps, but there aren't that many production deployed humanoids, right? So it's a little bit. It's very biased towards development, towards the development stage, simply because of the humanoid business model, right? They're not far enough along to where they are, deployed in large scales in production. So perhaps it might be more constructive if we started with, 2D robots, right? Mobile AMRs operating either in warehouses or, front of the house applications where fleet sizes can be in the thousands. I'm thinking like Bear Robotics with their restaurant robots, or the warehouse robots, Fetch, Locus. There's many others, of course. And then perhaps one other dimension to consider is the scale of the business, because that tells you, or maybe scale of the business is not so important, but the stage of development, which really reflects in the size of the fleet, right? Because when you have 10,000 robots, you will upload very different things than when you have 20 robots. When you have 20 robots, you may still upload a lot of video and endpoint cloud data and so forth, because you're really you're still getting from 90% reliable to 95% reliable, or maybe from 95 to 99. But once you care about getting from 99.0 to 99.9, you have to do it at a fleet size of 1,000. You have to think in different terms, right? You have to think more in terms of data that you can aggregate, rather sort of a point-to-point, not point-to-point, like per robot kind of analysis.
So definitely we can consider size of fleet. I figure that the bigger the fleet that you're making, the shorter the box becomes.
That's a good point. Yeah.
The conversation we've had, I've taken a lot of notes. I think what I'm hoping to do is, after this meeting, draft a blog post trying to describe what we've got. So for 2 categories, this is the data that's important. So I'd still like to capture that. But also what we've discussed with the triggers, like on-demand trigger, so automated because you detect an event, but you can't always detect something, rolling window, that kind of stuff. So I'll try and draft something that gives some general recommendations, and then for specific applications, consider this important. So I'm happy to switch humanoid to AMR. I think that was the two categories that popped into my head when we had the meeting. So very happy to change. So yeah, I think now it would be good to capture what we think are the most important data for AMRs and for submarines. And I think this chart is now not useful. Let me understand that. So for AMRs, what do we need to know? What's the most important?
So there's a this gets a little bit to the purpose of the data. So the one approach that we used at Savioc that worked really well for us was that we did think of the software development lifecycle, right? You write code, you test it, you deploy it, you find issues. When you find issues, normally you just fix your code. But it's also good practice to not just fix the bug, but also to add a test case, so that if you had that test case in first place, it wouldn't have gone out into production, right? Now, I think in one philosophy that I really like in robotics is to say, well, in robotics, that is still not enough. You want to fix the bug, you want to add a test case, but you also want to add a health monitor in production. And what I mean by that is a sort of, think of it as a software sensor, right? Just some monitor in production that sort of gathers data, that first of all detects the problem before the customer calls you and tells you, like, your robot stinks. Detects the problem, and ideally already collected all of the data that you need to find it, and maybe even do what is called predictive maintenance, right? Where you, or predictive, there's a term for it, predictive.
I mean, predictive maintenance is very familiar to me as a term. So
I thought it was
AWS.
PMS. Yeah. Anyways, you know what I mean, right? So basically, you're trying to also gather data that allows you to predict whether something is about to fail, right? Like, that's in machinery, that's very popular. I worked at Xerox back in the day at PARC, actually, the Palo Alto Research Center. And one thing that saved them a ton of money was when they developed a model that would basically predict when a deployed Xerox printer was about to fail. Why did that save them so much money? Because they were actually not selling the printers, they were selling print services, and they sold an uptime guarantee. They would say, if your printer is down 24 hours later or something like that, you will have a working printer. We'll guarantee it. It's part of our deal. It's like an SLA. Now they own the problem of fixing these things. And of course, if you have to rush it because the customer calls you and says it's broken, that's much more expensive because you have to fly somebody there, whatever, with the parts. If they were able to predict, okay, not the toner that would run out, but like a part is about to wear out, right? And we'll send a technician ahead of time before it breaks. You can plan for it. You can send the parts to a forward stocking location. Anyways, you can save a lot of money. So same in robotics, right? If you can predict that something is about to go wrong, right, and you can notify the developer already. So anyways, I am getting back to your question. And that is, I think what's most important to capture for mobile robots is actually what the developers have specifically put in. Like, you want to enable your developers, you want to make it really easy for your developers to add things that they want to both capture and then also be notified about. Right, so it's typically along the lines of telemetry, right? A good example is a localization engineer, somebody who's focused on improving localization. They will typically want to know every time there's wheel slip, right? Which is something that you can typically detect in a combination of odometry and IMU, right? Like, if your IMU says, well, I haven't moved, but your odometry says, well, but I've spun my wheels a lot, well, that's a good indicator that you were actually skipping, right? And then the question to the localization engineer is, well, did the localization stay good, right? Because these are sort of the input variables that they use a lot to make sure that normally you want to trust your odometry, but in this case you shouldn't. So enabling the developers to make it very easy to collect that data and then also be notified, I think those are very those are some of the most important things to capture.
So I like that. We can think about things that go wrong in AMRs and what data would help debug that. So you said IMU, you said odometry. Pardon me. Telemetry. And then you can start to include things like camera data. Were you about to make a comment about telemetry there?
Telemetry, yeah, telemetry. To me, IMU and odometry are almost part of telemetry.
Yeah.
It's not important, but yeah, I guess partially what I'm saying is it's less about what you want to capture. It's more about the mechanism that you provide to your developers to change what they want to capture very easily. But maybe that's too much of a tangent of this discussion, because there is still the question of what is the set of things that you may want to capture, and then how easy it is to turn it on and off can be handled separately. So yeah, no, I think what you have there is quite good. I guess the other thing that I'll add is these are, sensor data. These are kind of real things. But then there's also the the things that, like the intermediate, the derived, like the derived data. Like when you, so for instance, you run AMCL, right, like a localization package. You would like to capture the confidence of the pose, like the distribution. Actually, one thing that a lot of people do keep track of is the sigma, like the variance.
Particles. Yeah, you visualize the particles.
Exactly, because that's obviously a good measure for how uncertain the localization module is, and if it spreads out a lot, or if it's even bimodal, then you may be mislocalized, or there may be uncertainty, and then at that point you would probably want to look at the odometry and IMU and laser scan very precisely.
That makes sense.
So I don't know how to capture that here. It's like, it doesn't have a good name, right? It's more like, yeah.
So here I've listed it as calculated state, which doesn't have the particles from AMCL, but I think it's a similar idea. It's I want to upload when I think I've detected an obstacle, as well as the data surrounding that.
For some reason, your screen share is not updating for me, but my connection is also not very good, so it may be on my end.
No, it's my fault. I keep selecting the tab to present rather than presenting the whole window. So let me switch over. It's clearly I don't know how to use Google Meet very well. There we go. Yeah, so of the data that we listed, there was some sort of telemetry, joint states, poses, accelerometer. So you would include odometry as that. And then there's calculated state. So what commands has it been sent? Has it detected an obstacle? Is it a member of a swarm where other robots are around that's affecting its behavior? That kind of data. So I think we've captured some of that. I think what you've said is not in that list though. So variables used for localization, algorithms.
Yeah, very good question. How would you call that? Almost
the thing that was interesting was the confidence you were saying how confident you are in the localization. So that's the if you want the aggregated measure that is interesting when you're doing localization, which is also represented by how spread out the particles are in AMCL in a particle filter. But you were, again, when you gave the example with the development life cycle and the bug fix and then the test, and then somehow creating a monitor in production on the deployed robot to check for the bug not happening again, or and maybe collect that data if that's happening again, or maybe notify the developers. Again, basically, we were talking about this tangential issue of turning on and off what you monitor and what you log. What are the ways? I mean, you mentioned, so okay, you were basically collecting a ROS bag on the instant, on the fly when this was happening. But is there? I'm not aware of any other way of doing this in ROS than somehow adjusting the logging and adjusting what you're collecting dynamically, other than starting a ROS bag collection. I don't know if now ROS bag allows you to, by service, turning on and off the subscriptions that you have in the ROS bag client.
That's a good question. I think there might be. That's not how we did it. There was a lot of custom stuff going on. One big discussion that happens, or one discussion that I've seen recurring in several robotics companies, is the question of, should you always record, right? Like this black box idea, so that you can do, so that you can see the last 5 minutes or 10 minutes or whatever, if post hoc, an event occurred and you would like to know what happened ahead of time. It seems like a really straightforward idea. The question there is, of course, always, well, what is it that you always record, and how big is that, and how much does that tax your resources, and so forth. I don't think ROS has a best practice, or definitely no package that automates any of this. But I don't even think there is much of a best practice in how to do that. But maybe it should, and maybe this is something where we can at least make straw proposals as to let's structure the problem a little bit. Let's put names to it. Let's ask what are the dimensions, right? Like we already discovered, like the moments, right? How do you define the moment of when you want to record, and is it a manual thing, or is it an automated thing, or how do these things combine? In our case, a lot of times it was that we actually, with new software releases, we would hard code what is being captured, right, and then define trigger conditions on that. We actually exploited the ROS diagnostics package a lot, which is just a structure for health monitoring, right, which really allows you to just publish to a topic, ROS diagnostics, how healthy a component is, that you can name it, right? So you could call it whatever, localization confidence, right? And you publish both health values such as okay, worn, error, stale, and then also some actual values. And then what we actually did, that was where my team came in, we just made sure that data propagated to the cloud for storage, but then also to the web for visualization, so that our field operations team could see, oh, there's a warning on that robot, and the customer just called me, told me that something's wrong. Well, let me put one and one together. That might be a clue, right? Because a lot of times triaging issues and finding out where the actual causes can take a long time. But if the developer has been kind enough to ahead of time sort of put in the sensors to say, like, well, there could be an issue at one point if we see such and such happening in the field, then that can be useful. So I mean, to answer your question, in our case, it was not so dynamically turning it on and off, but it was more about software releases, like .0 releases. We would have a lot of instrumentation in the code to check on the things that we think we fixed or hope didn't break, and then over time we would turn them off again.
I found it very interesting what you said when you said, should we record everything? Should we always record? And that is somehow maybe a good mitigation strategy, right? Combined with your ROS diagnostics, with the messages that you put on ROS diagnostics, you could say, okay, I'm recording everything at all times with a rolling window, so just the last 2 minutes of everything. And whenever I get an event of ROS diagnostics, which is an error, that's where I kill the ROS bag process so that it saves everything in a database, and I start the recording on a rolling thing again. And then you could ship only that snippet of the last 2 minutes. That could be a general purpose strategy for collecting okay, combined with a good sensing of ROX diagnostic if something went wrong, because that's the secret sauce that makes it all work. Otherwise you record too much and it doesn't work. But it ties in also when you were mentioning you could use ROS diagnostics to warn developers or to warn people that are monitoring the fleet. That also ties in with what we were discussing in the previous calls about fleet management and about the fact that on a dashboard, this triggering event of a warning could be the same event that actually triggers the saving this ROS bag and saving the data, the monitoring data.
Yeah, and the other component that is still like even more outside of today's discussion is then just notifying the developer himself, right? Like a lot of times we would have, we used Slack a lot, and Slack is very nice in terms of the API for notifications. So we would have channels with alerts from the robots, and we would then send a message such as, we think robot 123 is mislocalized, right? And then because when you have that rolling window, you also need to be quick enough to get the data in case it's not automated already, like you described, right? If you just think that you might want to keep it, you have to go there fairly quickly before it gets deleted.
I don't think this is too outside of the discussion, because one of the reasons that you'd want to upload to cloud is that you can process data in a very scalable way and then communicate with people. So yeah, I think one of the discussing a mechanism for doing that is a good idea, and the diagnostics is a good idea for that detection.
And I'll do a little plug for something that almost everybody pitches when they talk to VCs, and that is we'll do automatic anomaly detection, right? Like everybody has been wanting to do that. Turns out to be really hard. But that would be the holy grail, right? Where the monitor, where the software is smart enough to realize something's changed here, something's fishy. We probably want to look at that without having to pre-specify that, right? I have not heard of anybody really being successful with that, but it sounds really cool. I mean, in theory, anomaly detection. I don't even know whether in other industries that has borne any fruit. I know in cybersecurity they've been thinking about that, but I haven't tracked it. I don't know, Giovanni, whether you've come across anything like that.
Two things. I remember, yes, something in cybersecurity which more or less works similarly to something that I wanted to do in robotics, which was what I wanted to do in robotics, which is the easiest example, is I always use distributed robotics. So I always have some components that are running remotely on the edge, and I always have some components that are running. And many times there's simply topics that don't come through, or topics that are delayed, or they're not coming at the right frequency. And the dashboard that I always wanted to build was something in which I would say, okay, the system is now working in nominal state, is working as it should be. Click a button, take a screenshot or a snapshot of all the bandwidths, all the data rates for all the topics that are being subscribed in my distributed system. And if anything is not respecting those rates, turn it red on a dashboard. And as a matter of fact, I saw very recently somebody on this course that published a dashboard that does exactly something like that, where you can say, this is my expected rate or my expected bandwidth for this set of topics, and if this is not the case, just turn it red. They don't do the anomaly detection themselves, but you have to specify what is the expected rates. But at least I would have the nice, beautiful dashboard that would be able to show me, there's a possible reason for why this algorithm is not reacting quickly enough.
I love the idea. I think the key in what you say is actually the first part, which I have not heard enough people talk about, which is just training what is normal. I'll have to reference again my new favorite book. I told you about it before, the Brief History of Intelligence. So he's describing that one thing that the brain does, it's called latent inhibition. And that means that all the time, you are learning things that are not happening, right? So for instance, sitting here, does not cause, I don't know, my light to flicker, right? Well, why should it? Okay, but you know, I am also learning, you know, latently that a lot of things are not happening. I'm really fascinated by this concept, because in AI we've seen this in different shapes and forms. In logic, this is called the frame problem. I don't know whether, Giovanni, you've come across that, but the frame problem in logic was in you know, logic for robots, was that when you actually, it was John McCarthy who first framed that. When you want to specify what is called an action theory, meaning you want to specify in logic all of the effects of an action, you know, such as, you know, me picking up a glass, it is very difficult to actually capture everything that does not change due to this action, right? Because, like, and it sounds so silly, and especially once you hear the solution that Ray Ryder later came up with was to make a closed world assumption, where he basically says anything that you don't specify actively as an effect is a non-effect. So, for instance, me picking up this glass does not change the color of my sweatshirt, of my sweater. And of course, you know, you and I know why would it, but as a robot, you need to know that. And I think this is very related to latent inhibition, right? Because in the human brain, you learn that through observation, right? You do this a number of times, and you realize there's a lot of things that are not affected by that. That's why this training of what is normal, as boring as it sounds, is so important. Right? A lot of people train on the things that they want to detect. Oh, you know, there was a this and that happened, so let me show you how to discover that. But it's also so important to, because you can't define a line with just training on one side. You need to, in ML we know that, right? You need to have positive and negative examples, but we need a lot of negative examples, which is where this idea of normalcy comes in. I think that's also where anomaly detection has problems, right? Because one thing that throws it for a loop, I think, are software updates, right? Like, so for instance, in your example, okay, so in version 1.1, we changed the frequency between this node and that node, and this is now the new normal, right? Well, you don't want all of your alarm bells to go off just because you released a new release, right? I don't know. I guess you could retrain it, but I don't know whether there's good solutions to that. But I'm glad to hear that there's now people working on it.
Yeah, at least on the dashboard part, but not on the anomaly detection. But and indeed, I think the biggest problem with automated anomaly detection is exactly what you were discussing. A wanted configuration change would be an anomaly, of course, if you just use a learning model, and that wouldn't really cut it. Wouldn't really help there.
Yeah, one thing that would be really fun to do, and now I'm just brainstorming, and maybe this is going too far, but we only have 5 minutes, so if I derail the conversation, I can't do too much damage. One thing that would be fun to do, actually, would be to do an automatic normalcy detection, right? So rather than anomaly detection, first train to detect what is normal. And I think there you can actually lean on the business model of your robot. So in the Savio case, if you have a lot of successful deliveries, right? Okay, so whatever, right? You deploy your software to 100 robots, and you observe for the first week, and you take all of the successful deliveries. I think it would be a fairly good assumption to assume that these robots were doing well, right? Like, whatever they were doing, it was normal. It didn't have, maybe it had some anomalies, but they weren't big enough for you to care. And then based on that, learn what you were doing manually, to just say, okay, this is good. This is what good looks like. Now tell me what is different from that. Right? I don't know whether that could scale.
I think with the tools that we have now, with the AI tools that are available, this is what people claim that they are able to do. I haven't yet tried to use them myself. But while you were mentioning the anomalies, at least with rates and these sorts of things, it reminded me of Nav2 and the navigation framework, for instance, which is so distributed. But then in the configuration, you are somehow specifying the expected or the desired, actually, control loop that you want to have for everything. Mm-hmm. And as soon as you have a delay in the flow between the sensor and the cost maps, for instance, you realize pretty quickly that warnings come up right away. So in those systems, it's actually already built in, the anomaly detection.
This is I mean, that sounds very much like declarative programming, right? Which is, of course, in my mind, often the answer to all questions. In declarative programming, obviously, you don't specify what the robot should do or the system should. You don't tell it how to perform, how to act, right? Like in procedural programming, but you say what it should look like what it should be doing in some ways. And of course, in planning, we use that a lot. I mean, planning is all about is very declarative. You specify the goal and the actions, and then the robot figures it out. Prolog, right? Declarative programming does virtually the same thing, right? You want this clause to be true, now prove it. And in some ways, what you're saying is similar. The nice thing about declarative systems like this is you can use it both in a procedural way. Like so in the nav2 example, if you specify the rate, well, you can automatically write some code or configure some code that will publish at that rate. But then because it is defined declaratively, you can also use it for testing and checking, right? This is, I guess in software engineering, they do this, is it called BDD, behavioral or TDD, like test-driven development?
Test-driven development, yeah, TDD.
Behavior-driven development. Similar idea, right? You basically specify the test case and then you make sure it works. But if you do it in a declarative way, you can automatically generate code and test against that. I think that's a very good point for what we're discussing here.
2 minutes left. We should probably wrap up. I think my idea now is to try and write some kind of post with what we've described so far. And then once I have a better idea of what's needed in the post, I can either announce that for the next meeting or we can have something else. My request to both of you is if you can, while you're grabbing a glass of water and having a break, just think of some more topics for future meetings. I think it's already been interesting from the one we've had suggested, so I'd love to get some more. And I can't wait for our anomaly detection startup. We're going to make loads of money.
I'm thinking that it would be, I want to go back to the first thing that I said, which is that I don't think I know enough about this. It might be interesting to invite people from specific startups in specific, like you were breaking it down in specific robotic applications. And the submarine one in particular, right? Like I know very little about it.
We might be kicked out in a sec. Sorry, the call will end automatically.
Yes. Okay.
We can discuss this offline, but I think that's a great idea if we can invite some specialists, especially if Foxglove is doing this stuff already. I didn't realize. I can look more into that. So that would be good to get involved. I think it's as useful as possible. But yeah, thank you both. I think we're about to get kicked out, so I'll see you next meeting.
Thank you.
Bye.